Which distribution? Z, T, or neither? So far in this module, you've learned that a point estimate is a single value which serves as a best guess of an unknown population parameter. For example, a single sample mean obtained from a survey is a point estimate, since it may be used as a feasible value of the population mean. A confidence interval, an alternative to a point estimate, is a range of possible values the parameter might take, and the probability that the parameter does not fall outside this range can be controlled. More specifically, a confidence interval for a population mean based on a sample mean can be constructed. One method for calculating the confidence interval of the population mean is to use this formula: the sample mean plus or minus the positive z-score for a particular confidence interval times the population standard deviation divided by the square root of the sample size. Another method for calculating the confidence interval of the population mean is to use this formula: the sample mean plus or minus the positive t-score for a particular confidence interval times the sample standard deviation divided by the square root of the sample size. How will we choose which formula to use? Let's look at both formulas on the same slide so that we can more easily compare them. The sample mean, plus or minus the positive z-score for a particular confidence interval, times the population standard deviation divided by the square root of the sample size. The sample mean, plus or minus the positive t-score for a particular confidence interval, times the sample standard deviation divided by the square root of the sample size. Note that the two formulas are identical except for the two items displayed in red: z-score versus t-score, population standard deviation versus sample standard deviation. That means our question boils down to the following: when constructing confidence intervals for estimating the population mean, should we use the normal distribution, z, or the t-distribution, T? Note that the Z formula includes the population standard deviation, while the T formula includes the sample standard deviation. Recall also that as the number of observations gets larger, the T distribution approaches the shape of the normal distribution. Note that if the sample data have been collected using an inappropriate method, such as a convenience sample, it is quite possible that there is no statistical method that can be used to find a useful estimate of a population mean. If we assume that the sample is a simple random sample, we can use the information on the next slides to help us answer the question: which distribution, Z, T, or neither? Use the normal Z distribution if the population standard deviation is known and the population is normally distributed, or the population standard deviation is known and sample size is greater than 30. Use the T distribution if the population standard deviation is unknown and the population is normally distributed, or the population standard deviation is unknown and sample size is greater than 30. Use neither the Z nor the T distribution if the population is not normally distributed and the sample size is less than or equal to 30. Here are some tips for assessing normality. The population need not be exactly normal, but should appear somewhat symmetric with one mode and no outliers. Here are some tips for assessing sample size. A sample size between 15 and 30 may be adequate if the population appears to be nearly normal and has no outliers. A sample size much larger than 30 might be needed if the population appears to be far from normal. Let's practice choosing the correct distribution, z, t, or neither, for constructing a confidence interval for the population mean. Pause the video after each question is posed to give yourself time to answer the question. Once you've decided on an answer, continue the video to check your choice. 1. Sample size equals 8. Sample mean equals 65. Sample standard deviation equals 0.5. Population has a very skewed distribution. The answer is neither, because the sample size is small and the population is not normally distributed. 2. Sample size equals 20. Sample mean equals 38. Sample standard deviation equals 1.7. Population has a normal distribution. The answer is T, because the population standard deviation is unknown and the population is normally distributed. 3. Sample size equals 8. Sample mean equals 65. Population standard deviation equals 0.5. Population has a normal distribution. The answer is Z, because the population standard deviation is known and the population is normally distributed. 4. Sample size equals 80. Sample mean equals 65. Population standard deviation equals 0.5. Population has a skewed distribution. The answer is Z, because the population standard deviation is known and the sample is large. 5. Sample size equals 80. Sample mean equals 65. Sample standard deviation equals 0.5. Population has a skewed distribution. The answer is T, because the sample is large and the population standard deviation is unknown. In conclusion, when constructing confidence intervals for estimating the population mean, it is important to choose the correct distribution, Z, T, or neither. You can make the correct choice by answering these 3 questions. 1. Is the population standard deviation known? 2. Is the population normally distributed? And 3. Is the sample size greater than 30?